All right, today we're looking at the notes to solving multi-step inequalities. So the goal will be that you can solve linear inequalities with one variable using the distributive property. Remember, the distributive property is when you have something on the outside and you distribute using multiplication, and variables on both sides. So remember, you'd have variables on both sides of the equal sign. Okay? But we have these inequalities, which is something new. Inequalities uses four special symbols. So the first symbol is less than. And with the less than symbol, you are saying that something 2 is less than 5. Then we have the greater than symbol. And with the greater than symbol, you are saying something like 10 is greater than 1. The less than or equal to symbol, you're saying less than or equal to, means something like 2 is less than or equal to 5, or 5 is less than or equal to 5. So both of those things are true. The greater than or equal to sign is like saying 10 is greater than or equal to 1, or 10 is greater than or equal to 10. Both of those things are true. So they can either be less than or equal to, greater than or equal to, and in these ones, it is strictly less than, it is strictly greater than. So when you're graphing these, I'm going to start with this one on purpose. So this is saying x is less than or equal to 5. So in words, because we have x, we're going to say all real numbers. That's what x means. It's a variable. So in words, all real numbers less than or equal to 5. Well, I want to pull out this particular part. All real numbers equal to 5. What would equal to 5 look like? If I told you to graph x equals 5, what would that look like? Well, you'd probably go over here to 5 and you'd probably make a dot. And that's correct. And then now I'm going to tack on this less than part. I'm going to go ahead and do the less than part here in black. The less than part is saying, hey, all of this counts. The equal to is the dot. The less than is all this shading. So when it is less than or greater than, when it is less than or equal to or greater than or equal to, these dots look like this. So let's look at this one then. I purposely waited on this one for this reason. This is saying, again, x is a variable, so it's all real numbers. All real numbers less, greater than, I don't know why I'm putting an n on there, greater than -3. Well, here's -3, and I want all of the values that are greater than -3. But I don't want to include -3. I just want to know that that's the place I started. So what I'm going to do is I'm going to protect -3 by putting a little circle around it and defending it. Okay? This open circle means that that is your starting place, but you're not including it. You're including all of the values above that starting point. Okay, so that -3 right now is protected because it is only greater than, it is not greater than or equal to. So when you solve multi-step inequalities, the goal is to find the solution to the values of the variables that make the inequality true. Remember, distributing and combining like terms, this is simplifying. And here, adding and subtracting and multiplying and dividing, this is solving. Now, inequalities have this one weird hiccup. They're all the same steps, but when you multiply or divide by a negative value, the sign flips or the sign reverses. Here's what I mean. In problem number 3 through 6, all we're going to decide is whether or not this inequality symbol should be reversed or not. This is the only reason why. If we multiply or divide by a negative value. So here, I would divide by 5. So because 5 is positive, no, the sign doesn't flip. Here, I divide by 2. No, sign does not flip. Here, I would subtract by 4. Then divide by 2. So no, my sign doesn't flip. Here, I would divide by negative 5. So yes, my sign flips. So this is negative 2 over 5. Let me show you why. Here, we're going to do something called the zero test. What we're going to do is we're going to try and see if 0 works, right? So I'm going to take this, I'm going to say negative 5 times 0 is less than or equal to 2. Anything times 0 is 0, which is why I like the zero test. 0 is less than or equal to 2. This is true. This works. If I didn't flip this sign over, if this sign stayed the same, this would be y is less than or equal to negative 2 over 5. That is not true. Multiplying and dividing by a negative requires this sign not to change, but reverse or flip. So let's go ahead and solve these. This, ideally in class, this one we would work together, this one you would work with a partner, and this one you would do on your own. So problem number 7, I have distributing. I'm going to go ahead and do this real quick. Don't call me after midnight. So I'm going to go ahead and start with distributing. I distribute that negative. Nothing happened to the 7y. It stays the same. This becomes negative 6. Negative times a negative makes a positive. My greater than symbol stays. I'm going to draw a little line right here. I'm going to distribute this 10. 10 times y is 10y. 10 times negative 1 is negative 10. Distributing. Done. Combining like terms. I'm going to go ahead and do that in orange. I can't combine anything over here. I can't combine 10y with 10. I can combine 7y with another y. 7y's plus one more y, that is 8y's. I didn't do anything with this negative 6. So nothing happens to it. I combine these two. And again, nothing happens with this 10y minus 10. Everything that stays the same, I'm keeping in this purple color. All right, now we're going to switch to pink for moving the smallest variable. We want to move the smallest variable. This is when it's important to move our smallest variable. So what's smaller, 8y or 10y? I'm going to subtract by 8y. This cancels away and goes away. Nothing happened with the negative 6. It's just chilling. 10y minus 8y is 2y. You see how that stayed a positive? If I move the 10, it becomes a negative, and then I have to use this rule, and I want to avoid negative variables. Nothing happened with that negative 10. Moving the smallest variable is done. Hey, that 10 is supposed to have a 1 in front of it. Why didn't that show up? Okay. Step number 3. Now, or step number 4, excuse me, add or subtract. I'm going to go ahead and add 10. Now I'm solving and I'm trying to get y all by itself. 10 minus 6, this is 4, is greater than 2y. Nothing happened to the 2y. The 10s go away. My last step. Heyo, adding and subtracting. That needs a check mark. Last step, divide by 2. My final answer, 2 is greater than y. So, because this symbol ended up looking like this, because our y is on this side, it reads differently. So, what I would do in this situation, okay, if you want to graph it, that's fine. Here's 2. First, is it equal to? No. So immediately I put my bubble around it. Now I have to decide, do I want the y values going this way or do I want the y values going this way? So if I put a number out here like 5 and another number out here like 0, which one would be true? Is 2 greater than 0 or is 2 greater than 5? This one's not true, so I would shade this way. Because our variable is on this side, we can't just assume like we're going to shade to the right because it's the greater than symbol. We're saying 2 is the greatest amount. We want all of the numbers less, or we want 2 is greater than all of the numbers. 2 is greater than all the numbers. Now, 0 works, and we can do our 0 test. Again, here's how the 0 test works. We take 0, we plug it in, and we see if it works. Is it supposed to? Yes, because it's on the shaded side. So let's try it out. I'm going to pick a color that I've not used before. Hopefully this works. All right, so this is 7. Wherever y is, I'm going to put a 0. So 7 times 0 minus 6 minus 0. So I just rewrote this and I put zeros there. Is greater than 10 times 0 minus 1. Okay, 7 times 0 goes away. 6 minus 0, that's 6. And this becomes negative 6 because I distribute this in. So this is negative 6 is greater than 0 minus 1 is negative 1. 10 times negative 1 is negative 10. Negative 6 is greater than negative 10. So this is true. 0 works. We did this correctly. All right, now working with a partner. Again, step number 1, distribute. I have parentheses. Let's distribute this out. 2 times 3 becomes 6 times, subtracted by negative 3b. Is less than. There is no distributing on the other side, so that stays as 28 minus 3b. Awesome. Distributing. Done. Bonus, there are no terms to combine, so combining like terms. Done. Awesome. Let's move on. Move the smallest variable. I have negative 3b over here. I have negative 3b over here. So I'm going to add 3b to both sides. Uh-oh. My 3b goes away. I'm left with 6 is less than 28. So here's the question. Is that true? Is 6 less than 28? Yes. True? So this goes back to that lesson. Whenever we had a true statement at the end and our variables went away, this means that all real numbers work. It doesn't matter what number you pick, it will always work. That one was a little tricky. All right, this one you're supposed to be doing independently, but I will walk you through it so in that way you can see if you got your answers correct. First, distribute, combine. Don't call me after midnight. Step number 1, distribute. Hey, we got parentheses. Let's go ahead and distribute. Distribute. Nothing happens to the 3n, it stays there. Is less than or equal to 3 times 3n is 9n, plus 3 times 6 is 18. Distributing. Done. Combining like terms. There are no like terms to combine, so that is done. Fantastic. Move the smallest variable. Now, we're going to have an issue. If we move the smallest variable, we would be moving this 3n over to here to 9n, and then we'd be left with nothing on this side. You can do that. It's not that big of a problem. However, here's what I'll show you. We can go ahead and subtract by 9n. So if I subtract by 9n, I get negative 6n is less than or equal to 18. Okay, I move the smallest variable. Done. Add or subtract. I actually don't need to add or subtract because it's just a variable term all by itself. So my last step, multiply or divide. Here I would divide by negative 6. And n, 18 divided by negative 6 would be negative 3. So here's the question. First, open or closed? This would be closed because I have the equal to. So I go here to the negative 3, and I close it. And I need to know, do I want the values above or below? So here's my question. Does 0 work? You see 0 just lying here looking at us like, hey, test me, I work perfectly. Let's try it out. And this is why I like trying 0 out, because this double checks me. 3 times 0 is 0. It goes away. Less than or equal to 3, parenthesis, 3 times 0 again, plus 6. 3 times 0 again, that goes away. 3 times 6 is 18. So 0 is less than or equal to 18. Is this true? Yes, 0 is less than 18. So I would shade this way. But if you look, my original symbol said less than. It flipped because I divided by that negative, so I had to flip the sign. Using 0 as a tester allows me to double check myself on which way my sign is supposed to go. If I ever multiply or divide by a negative value, that flips. Okay? So multiplying or dividing by a negative causes the sign to flip. You could have also moved this 3 over, and then you would have moved the 18 over, and then you would have divided by 6, and you would have had negative 18 divided by positive 6, and you still would have ended up with 3. It would have just read as negative 3 is less than or equal to n. So again, it becomes this issue of which way do I shade, and I would want to test 0 out. Inequalities, the biggest thing is if you can get through this part of the solving equation part, we can test 0 to see which way we shade. And those are our notes for solving multi-step inequalities. Thank you.